Cool, that's what mine looks like. A couple basic comments about mine. I just gave them some sizes, right? So mine's a 4x4 and an 8x4. You can make them however big you'd like, right? My floor is 100 wide, and basically what I'm doing in mine. Oh, first off, why do I have a floor? Sorry?
For distance, so you can see how far it moves.
Partially so I can see how far it moves. What happens if I don't have a floor and I go off the edge of the screen? The camera does weird stuff, is the answer, right? So I basically stick this in here so that I can basically have it collide, have it stop at a reasonable distance, and it will all look hopefully okay. Right? I'm going to kill this stuff over here, Mr. Page.
Yeah, sure.
Cool, second question. Even if you didn't do this, talk to your neighbor. Why did I stick my position here at 50, negative 3, 0? Talk to your neighbor. Cool. First question, why 50? Somebody with a hand. Jonathan.
Put it in the center, and if you change it to the size of 100, it goes 50 on each side.
Mm-hmm. Beautiful, right? So it's size 100, so I basically, right, this is my x-axis, right? Looks like that. Right here. Something like that. Cool. Why negative 3? So that it is lower than the boxes. Okay, what happens if I put 0, for example? Right, they're overlapping. Why did I specifically pick negative 3? Why that number?
Because your boxes, you made your size, your boxes at 4 in terms of the Y size.
Mm-hmm.
And so then it'll go 2 up, 2 down, so the negative 3 is below the 2 by 1.
Yep, so the negative 3, so why didn't I pick negative 2?
Because then it'll still be over.
Is it a side of 2?
Right, so we got 4 and 6 here, so this guy's 2 above, 2 below, right? And then my floor is too tall, right? So I need an extra one, right? So this is my negative 3 spot here, right? Negative 350. Right? Now, you'll note that you don't have to pick those exact numbers. You can pick whatever you want, right? Just make it look semi-reasonable. Yes, ma'am? I haven't tried it yet, so I don't actually know if it works. Mine's beautiful. What's that? Cool, talk to your neighbor. Yeah. Cool, so step 2. We need to give one of our boxes some speed. Which one's a logical one to give some speed? Could do both, right? Maybe we'll just do one in our little example today. All right, so I'll have box 1 V0, right, is equal to, I don't know, some speed, right? We want them to collide in a reasonable amount of time. This guy is currently 20 meters to the right, so maybe I'll give it a speed of 5 meters per second, right? And then maybe we'll do B1, B2, V0 is equal to 0 meters per second, right? That way, if we want to change it, we can, right? Cool. So the general structure for this program is we want to have, there's basically like 2 parts of this problem, right? Part number 1 is have this guy go over here. Actually, if anybody suggests, what are my 2 parts of my program? Like, what's actually going to happen in this that I want to illustrate?
A collision in which the force is, the momentum is completely transferred to the second block.
Beautiful. Not completely transferred, right? We're going to have them stick together, right? We're doing the Velcro example, right? So what are my 2 parts of my actual thing that's going to happen?
You know, the first part of the left box turning into the right box.
Uh-huh.
Second part, both boxes moving into the
Beautiful, right? So maybe we'll stick a little comment in here. Part 1, pre-collision, right? Beautiful. Cool. What things we need to do to set up this?
Have them both moving at an independent, like at a speed with a velocity,
I agree.
and then have them meet, like come together.
Cool. How do we actually make a move again? Some sort of while loop. What do I need to make before my while loop? Time. What should it start as?
0.
0. Cool. We got a while loop. All right. When are they actually going to collide? Talk to your neighbor. Brian, when are they going to collide? When they're at the same position, close. Does anyone have a better answer than that? I heard the same thing from a bunch of groups, so you're totally in good company. When the x-coordinates is the same, a better answer than that.
When it's like a little bit over to the left of it, just so the sides of the box touch.
Beautiful. If they're at the same spot, then we're only going to be able to see one box because they're going to be on top of each other. Right? So we want them to collide when this guy's right here. Yes? Right? So in my example, when is that going to happen? 16? Why 16?
This left moves over left 2 and the right moves over.
Beautiful, right? So this guy right here, this is 20, right? So this spot is 18, right? So we want this guy to be at 18 and therefore the middle to be at 16. Right? So while box1.pos.x is less than 16, right? We got to do a few things to move them. Number 1, update time. All right, I'm going to do our typical 100 frames per second. So t plus equals 0.01. Rate 100. All right, then we want to advance our box along. Cool. Cool. Cool, figure out how to advance your box along. Take 2 or 3 minutes. We'll check back in.
What kind of math equation? I'm going that way.
Yeah. So in our situation, we were left to put 16 in the wild loop because we set the velocity of box 2 to 0. What if we had a velocity for box 2?
Oh, great question, actually. What happens if we had a velocity for box 2? How would this change? When are they going to collide?
Later farther box 2.
Yeah, where exactly?
Box 2 dot pause minus 2.
Box 2 dot pause minus 4. Right? So that's actually a better answer here. Right? Box 2 dot pause dot x minus 4. Right? Once those are equal, then they've collided. Yeah, good catch, Ryan. Cool, so have your box advance along. Unexpected token, pumped, curly brace. Cool. I'm going to give the same recommendation I've given a few times, which is Trinket is nice to look at, but their debugging messages are bad. So I would take all of it. Yep, it's partially that. You need colon, yeah. So yeah, that's job speak. There you go. Cool.
It's just going too fast for me.
Run it again. So your issue is this here. So you're using the current position of the box these times. You want to use the initial position.
Oh.
So you see this.
So I need to actually put like box one dot pause dot x initial.
Yeah.
Box one dot pause.
There you go.
X and
Then
then
use. Yep.
box.
Is it hurts?
Just
Just
times
Like that.
Yep, I think that'll work.
See.
Move. Thank you.
Awesome.
Yep.
top it off. Is it working?
Mine's
So you remember how to make the box move?
So size is equal to 4.
Right.
Oh,
So
shoot,
you
you're
have-
right.
you
You're
have
right.
a new-
Yeah,
So you want to update this position every time.
Yeah.
Do you remember x equals x0 plus v0 times t? So you need to define this first. That's my mistake. So I made a line in here, which I called like box 1 dot pos dot x, and I called it 0. And then I set it equal to box 1 dot pos dot x. So I initially gave it its position, and then when I wrote this line down, right? Then I said this, and then I said it was, then I wrote this statement, and then I took v0, which is what is that? This is defined by him by b1 v0, right? And then multiplied by t. Does that make sense?
Oh, I get it. Okay, thank you.
See, I didn't make that. I made the mistake of not defining my initial position, right? You also kind of cool to be input this in. Like,
Yeah, we
we
can-
should do inputs as well.
We could do that.
So they can vary it. Because what I'd like to do is, I like this idea of putting this minus 4,
Mm-hmm.
right? So you subtracted 4 because this was 8 wide.
Yeah, 4 is actually wrong.
Is it
Yeah,
2?
Katalia had a good catch. I actually have a typo in here. Right? This minus 4 is incorrect. And that's because this thing is 8 wide,
And the other's
right?
2.
And the other one's 4 wide, right? So it should be half of 8 plus half of 4, right? So this should really be 6.
6. 4 minus 2.
Yeah. Is that what you were gonna say, Jonathan?
I just combined an 8 up.
You had yours. Oh yeah, you had yours 8 up. Yeah. So it's whatever you have for your code, right? Cool. Do we figure out how to get him to move? Can we get a hand? How many people got him to move successfully? Cool. Where are people struggling in that? Just don't remember how. Errors, whatever. Unexpected token. That's some sort of variable that you haven't defined. Yep. So generally speaking, our equation for position, right? X is equal to x0 plus v0t, right? We have no a in this scenario, so I'm just going to leave it out of our equation. All right, so that's the equation we're going to be using. All right, you'll note that we have not actually defined x0. All right, so we'll have b1 x0 is equal to box 1 dot pos dot x, and then I'm going to use that in my equation down here. All right, so the current position, right, box 1 dot pos dot x is equal to the initial position, right, b1 x0 plus v0 times t. So plus b1 v0 times t. Right, you'll note that if you give some initial speed to b2, you'll have to do the same thing here. So we could actually just code that in here, right? Box 2 dot pos dot x is equal to b1 x0 plus, sorry, b2 x0 plus b2 v0 times t. And then again, same idea up here. We'd have to copy that and change that to b2.
And this is if the other box is a velocity.
If we give the other box some initial velocity. Right, so this guy here and this guy, maybe I'll just stick a little comment in here. Right, so if we actually give them some velocity, then we'll need these two lines. Without them, we just need these two, right? So store our initial velocity and then advance our thing along each time through our loop. Cool. At this time, right, if we run it, we should have some stuff that actually moves along the screen. Should take about 2 seconds, 3 seconds to get there. Oh, it's so good. It's amazing. I can't believe it. It's wonderful. What basic thing can we add to make this easier to follow? Fireworks, sure. I guess I'm thinking more basic than that to make this, yeah, color, right? Stick some colors into your carts. Whatever, purple. I don't think purple's a color, actually. Yep. They're basic HTML colors. So teal is a defined color in HTML, but purple's not. Don't know why. Whatever. Red.
What about the floor?
Awkward. Maybe teal's wrong. Color equals color dot cyan.
See green. Like make it
There you go. All right. Part 1 done. Right? Cool. What is step 2? Or step 3 maybe. We've done some initial. All right, that's step 1. Step 2 is make it move until they collide. Like what should happen next? They collide, then what? They're not bouncing. We are doing inelastic collision. I agree, right? What do we need to calculate in order to figure out how fast they're going?
We take their masses.
Right, we got to do mass stuff, right? Figure out the momentums. Right? Cool, I'm going to leave that for you. Right? P, whatever, yeah. P initial, P1 is equal to something. P2 is equal to something. All right, I'm going to leave that for you to find those. And then whatever, V after collision is equal to something. You can call it whatever you want, right? V final, sure.
So we can set the mass to whatever we want.
Set the mass to whatever you want. Based on the size of your objects, right? You should probably give you some hints as to the ratio of your masses.